Hello, everybody. As you may notice, I am the only one here, and we are in a different studio. And that's because this is our first ever bonus episode. So, in today's episode, we're going to be going over AI technologies in the gaming industry, like upscaling and frame generation. I hope you enjoy. Okay, modern gaming tech is a mix of two things. You want to get the most detail you can out of every frame, and you want to get as many frames as possible, and it's hard to find a good balance between the two. So that's where technologies like AI upscaling and frame generation come in. Upscaling technology lets you run the game internally at a lower resolution, like 720p, and then upscale it using AI to a higher resolution, like your 1440p or 4K monitor. And there's different ways of doing this. A lot of different ways of doing this. So we're going to start with DLSS, which is NVIDIA's. DLSS is deep learning supersampling. It's trained on a ton of fully rendered high-resolution images rendered in games using a supercomputer. So it looks as good as humanly possible. So the AI, whenever it sees the low-quality version and it sees the best quality possible, and it tries to get the low-quality version to the best quality you possibly can as quick as you can so that you're not dropping frames upscaling. This allows your graphics card to only render in 720p and then let a neural processing unit, or NPU, upscale to your monitor's resolution. It can allow for way higher frame rates, and theoretically, you get like close to native quality. Nowadays, that is more true than ever, but there's still problems. With upscaling, it works with both rasterized games and ray-traced games. It has built-in anti-aliasing, and it can reduce input lag, and it runs completely locally on device. There's different versions, like they started with DLSS 1, 2, 3, then they released DLSS 4, which really good, and then they released DLSS 4.5, which was trained on way more powerful supercomputers, so it looks even better. And it is basically a generational leap over DLSS 4.0. With DLSS, you also get ray reconstruction, which allows your game to use less ray tracing, but the AI will try to add it back or enhance the ray tracing that's already there, which can make it look genuinely amazing. And then there's DLSS 5, which is a lot of controversy. There is quite a creepy amount of realism in there, like adding detail that was never there to begin with. And this kind of made game developers kind of mad because characters will sometimes get makeup added, they'll get smoother skin, exaggerated features, and they'll change, like it's changed the technology from just letting you get closer to what the video game designers wanted, but with higher frame rates, to just completely just making up stuff now. Another problem that it could cause is making all games look the same, with like the same color space and stuff like that. Though NVIDIA's CEO Jensen Huang said the developers will still have full access to like fine-tune and tweak how DLSS 5 works on their game, so hopefully it doesn't look too different. There are some major problems with DLSS, like not all games are supported, although most of them are, but like most big games are supported now, but still not all games are. And it has to be an NVIDIA graphics card, and it has to be a good enough one. So for like the latest ones, like you're going to need an RTX 50 series card, which are expensive. It is also only available on Windows due to the fact that neither macOS nor Linux support NVIDIA GPUs. One of the big problems that we talked about with DLSS is it only works on good NVIDIA GPUs. And AMD was like, hey, wait a minute. We don't make NVIDIA GPUs. Actually, a lot of people don't have NVIDIA GPUs. They should still get this technology. So they created FSR. It works on almost every single GPU you could possibly have running in your computer. It is trained on fully rendered frames, but that's only on later versions like FSR 4. Before that, it just used mathematical algorithms to try different things. Not to try different things, to try to add detail. So like DLSS 1 was specifically to make the edges of objects look better, whereas now it's a full AI model. Similar to DLSS, the game will run at a lower resolution and then upscale it to a higher one. Like you can render in 720p, upscale to 4K. I'm sure that use case does not look amazing, but both DLSS and FSR will look at motion vectors and depth buffers from the game engine itself to help predict what is about to happen, so it can upscale it more quickly and efficiently. FSR and DLSS both use temporal upscaling, where they look at the frame before and the frame after, and then try to create at least one frame in between. FSR will only do one frame. NVIDIA's DLSS will do up to 5 frames, giving you up to a 6 times frame rate boost. However, in FSR, it caused problems such as ghosting, which is wherever if you have a moving object on screen, or like let's say you look around with your crosshair, the crosshair will kind of blur as you look around, which does not look great. When AMD made FSR 3, they added the option for frame generation, which we'll get into in a minute. But it will add 1 frame for every frame that there's there, so doubling your frame rate. While NVIDIA required specific hardware, FSR does not, though it does work better on later AMD graphics cards, but it still will just run on small compute shaders within your normal GPU if you don't have one of those. Compared to DLSS, the images tend to look worse, but the gap is a lot smaller than it used to be, and it is still a very good option. It's better than none at all if your graphics card can't handle native, and the gap is getting smaller. Then there's Intel's, which I'm not quite sure how to pronounce. So let's see. How do we pronounce this? XeSS. Okay. Intel decided, screw everybody who wants to try to pronounce our technology, but let's make it available for pretty much everyone, just like AMD did. So they created what I believe is pronounced XeSS. If I'm wrong, someone correct me in the comments. Stands for Z super sampling. It's spelled capital X, lowercase e, and then 2 capital S's. It is Intel's technology for upscaling. It uses dedicated AI hardware if you have an Intel Arc GPU that supports it, but then otherwise runs like how FSR does. It uses specific cores if you have an Arc GPU that supports it, and one of the latest Core Ultra CPUs, like a Panther Lake one. That gives it way better performance. If you don't have it, then it'll just run on standard compute shaders, just like FSR does. It won't look as good, but again, it's still better than nothing. It actually tends to look better than FSR if you are running it on an Arc GPU that supports it. And it will look slightly better than FSR otherwise, but FSR will get you a higher frame rate. Now, a lot of you thinking, Apple is like, actually, no, probably none of you guys were thinking that, but Apple, they like to be like, hey, the Mac can game too, right? And so they decided to release Metal FX to compete so that it can have upscaling on your Mac. It only works on the Mac, but it is very, very, very well optimized. It uses the neural engine on Apple Silicon chips and can upscale the images for you. Early versions of MetalFX were very, very much based on FSR, which is open source, so it's okay. But then they're like, wait a minute, machine learning models are doing a way better job at this. So they released Metal 4 in 2025, and they transitioned into a fully custom machine learning pipeline. It was designed specifically to work with the neural engine on M series and A series chips. So your Macs and iPads and iPhones of the world. Because all the heavy AI stuff is happening on the neural engine, the GPU does not have to work as hard at all, because it can just render the game at a lower resolution, and then the neural engine picks up the rest and fixes it, makes it look better. Because it is so locked down, Apple knows exactly what processor it's running on and can optimize it for that specific processor and configuration you have. And so that is upscaling technology. We'll get to frame generation after the break.
While Colton and I may not agree on much when it comes to phones, laptops, computers, operating systems, or anything in general, there is one thing we can agree on, which is that you should check out the Wallpaper Press. They have really high quality wallpapers at an affordable price, and they fit literally every screen. They have wallpapers for ultra-wide monitors coming up soon. They got 4K, they got your phone, iPad, laptop, whatever Linux machine you're running, if you're like Colton, and just pretty much any style you want. So if you want your technology to look as good as it will run, or not run if you're like Colton, then check them out at wallpaperpress.com.
All right, we are back. We're now going to be talking about frame generation technology, which is where your GPU will generate frames that were never actually rendered. That has the same competition as before. It's NVIDIA, AMD, Intel, and Apple. So with DLSS, it offers up to 6 times frame generation whenever you're gaming, which is inserting 5 frames in between whenever it looks at frame A, which is rendered before, and then frame B, which is rendered after. We will get back to that in a minute. It inserts 5 frames in between those, though. Dynamic frame gen basically makes it so you don't have to use frame gen as much. So if you're a GPU, it can run your 1440p monitor at 360 FPS for whatever game you're playing. And then you go to fight somebody, and then the bullets, and then your frame drops down to lower than that. Frame gen will kick in and try to lock you to your monitor's refresh rate. However, frame generation technology adds some lag. So NVIDIA created Reflex, which basically tells the game engine the CPU is not going to leave a queue for the GPU. You are going, everything is going to be rendered at the last possible second. As soon as the GPU is ready to pull a new frame, the CPU is going to send it. So don't create a queue. So it basically makes the input feel a lot more responsive. Then AMD was like, we need some of this. They got FSR. Same technology as before for upscaling, except it's a different technology. It's just same name. On supported hardware, it'll use a machine learning model, assuming you're using FSR 4. And then it will do, if not, it'll just do what older versions did and use complex mathematical algorithms to try to generate frames. I'm not really sure how they do that. But it's still good, but it's not as good as using the A model or DLSS. It will generate 1 frame in between every 2 frames. So that's a 1-to-1 ratio. So it doubles the frame rate. It won't do what NVIDIA does, which gives you 6 times. And they have their version of Reflex as well called Anti-Lag 2. We'll get into that in a minute. Then Intel wanted their turn, so they created XeSS, but not the same one as before. It's different XeSS. While FSR can only insert one frame between every 2 frames, XeSS can insert up to 3, which gives you 4 times the frame rate. So not as good as NVIDIA, but better than FSR. But does it actually? Because you need a supported Intel Arc GPU. Otherwise, it's only 1-to-1, just like FSR. So womp womp. It uses ZEL, which is Z low latency, to lower the latency. And it takes the timing data of every frame and tells the CPU, wait a minute, don't send it. Send it. Last possible millisecond. So it only processes stuff as it needs to. This lowers the input latency by a lot. And just like FSR and DLSS, it is completely mandatory. If your game supports FrameGen, you have to have the anti-lag system. And then there's Apple. And they're like, hey, Macs can game too, right? Definitely. All games are supported on Mac. Developers, please make more Mac games, please. So yeah, that's what Apple wants. And the benefit with Apple is they don't have to account for every single possible configuration you could have in your PC. Because you don't get a choice with Apple. It's all stuff Apple makes. Meaning they can optimize it really well for Apple Silicon. The frame interpolation goes to the neural engine, freeing up the GPU to do more rendering of the actual graphics. And it is designed to use as little battery as possible while keeping the laptop as cool as possible. So no heat, no power draw, or not none, but less. The input latency for Metal FX frame generation is handled at an operating system level, which allows for very little latency. Now we are going to talk about the winners. If you're upscaling, which one should you use? Like if you're buying a graphics card, do you want to get an NVIDIA card? Do you want to get AMD one, an Intel one? You want to buy a Mac? Well, let's talk about that. When it comes to input latency for frame generation, NVIDIA's Reflex works the absolute best. AMD's older system, Anti-Lag Plus, that did not go well. There's a reason why there's Anti-Lag 2, because Anti-Lag Plus tried to insert files into the actual game's DLL files to try to speed things up. And in every single anti-cheat system ever was like, hey, they're changing the code of our files. That they're hacking. And so legitimate players started getting banned just trying to get a higher frame rate. So Anti-Lag 2 was born. It runs almost as well as Reflex, but it doesn't have the same widespread support because NVIDIA is the big flashy GPU that everybody buys. Now, while it might not work as well, Apple, they're like, hey, we're a tightly integrated ecosystem. So instead of having all these layers on top of the operating system, let's just let the operating system do the anti-lag and change the frames. So on a normal Windows PC, the CPU calculates the game logic. Then it has to package all that data and send it to the GPU. And the GPU has to take that data and put it into its own memory. This adds lag. So Apple uses unified memory, where the CPU and the GPU share the same amount of memory. So all the CPU has to do is be like, hey, look there. And then the GPU is like, oh, I see that data. And then a lot less latency. And because the operating system knows which frames are being pushed when and like what refresh rate to run the monitor at, assuming you have a MacBook with ProMotion, it'll push the frames as efficiently as humanly possible. Or not humanly possible because it's a computer, but you get the point. It works really, really well in single-player AAA games, but it's still more lag than NVIDIA's, in which case, if you're doing competitive online games, you just got to use NVIDIA's. I mean, now earlier, you may have heard me mention frame interpolation. Might be thinking, what does that mean? I thought that too. It's a great question. There is no answer. No, I'm just kidding. There's an answer. It's where the GPU or NPU will look at two different frames. The frame that was generated one frame before, and the frame that was just rendered. And then they look at frame A, look at everything on there. They look at frame B, look at everything on there. And they get the data like motion, like all the motion data from the game engine itself. Like, okay, object A is moving from here to here at this speed. Therefore, in between here, it should be here. So it creates the fake frame in between those two, pushes it to your screen, and you get a higher frame rate. Now, while FSR only does it once for those two frames, Intel will sometimes do it 3 times for those. NVIDIA is the best here and will do 5. So you get 6 times the frame. Now, we talked about the best anti-lag system for frame gen earlier. We're going to talk about winners overall. So, the best for frame generation total is NVIDIA if you are using DLSS 4.5 on an RTX 5000 series card. It generates the most amount of frames with the least amount of latency. Intel's XeSS 3.0 on Intel hardware is a very close second place because it's got 4 times the frame gen. And it does not require the most expensive graphics card. NVIDIA's main problem is it requires the most expensive GPU you can or can't buy. They're expensive. Now, upscaling, which is the best. Spoiler, it's NVIDIA. Again, DLSS 4.5, because they have a very good AI transformer model, because supercomputers, and it allows it to reconstruct extremely fine details like wire fences or text in the background of your image and just render it and generate the frames really well without many artifacts. It also has extremely good ray reconstruction. Now, second place. Maybe thinking, well, last time Intel was second place. It's AMD? And you'd be wrong. It's actually Apple this time with Metal FX. Because if you are running on a Mac display, it is extremely efficient with using the neural engine and letting the GPU render stuff, and it looks good. I personally use Metal FX whenever I'm playing Civilization 7 on a 4K monitor because why not? I mean, I want it to be 4K. And my computer is not going to run it at 4K. I mean, it will. It's just kind of laggy. So we're going to move on. We're going to talk about hardware compatibility. It is AMD's FSR4. Let's go. It's open source and does not require any specific GPU or hardware. You can run it on pretty much anything. And while it does run best on AMD's latest chips, it has really good fallback ports for whatever graphics card you have in your computer. Now, what about for battery life? If you're playing on a laptop, it's Metal FX again. It offloads the upscaling and frame generation to the neural engine, freeing up the GPU to do more rendering of real stuff. And It does not use very much battery, and it doesn't heat up your devices too much. It is the only reason you can play AAA games on your iPhone. Now it's time for my recommendations. If you're going to buy a new graphics card right now, in the year 2026, and you have an unlimited budget, I would recommend getting an RTX 50 series card and using DLSS 4.5. That is my best recommendation for if you have unlimited budget and are buying a graphics card. If you want your most current GPU to run at higher settings, FSR 4. And if you're on a Mac, with the exception of FSR, you don't really have a choice, and MetalFX looks better than FSR, so use MetalFX. Now, if you found this interesting, don't forget to leave a like and a comment or a review. If you don't like it, send it to your worst enemy. There's a dislike button if you're watching us on YouTube. And yeah, if you want to learn more about this technology and you want to hear more about stuff like PSSR, which is PlayStation's upscaling technology, or Microsoft's AutoSR on Copilot Plus PCs, let me know in the comments. Thanks for listening. Hope you learned something, and have a good week.